Because I sent you a person at a 100 it's workers. And so we have that first two bits. That's fine. All right. What else do I need to set up? Ah, yeah, today. Uh, so by the end of Tuesday, we were looking at polynomial, but I was just having grad with grad on the same old way. And that works. So again, you're sitting there on that, and I'm asking you to graph something, anything, it doesn't matter actually. And you don't remember some particular shape or way to get at it, you can always do the same thing. You pick a bunch of x values, plug them in, get your y values. That's it. What I want to look at today, though, is well, actually, let me get a little bit of input from y'all. So, graphing out the polynomials on Tuesday. I don't know. I guess horribly asked question, but how did that feel? Was it clunky? Did it make sense? Was I don't know. What do you guys think? It says. Don't say it made sense just because you know I want you to say that. But did it really make sense, or did it feel clunky compared to the other graph we've done? I guess. Yeah. Okay. Okay. So it felt kind of thing. That's where we want to go today. Let's do. Well, I think with this first problem, what I want to do then is I want to give you guys sort of alternative way to go, just an alternative way to go about ultimately getting the graph, but also answering the questions that they want you to answer. So they're going to ask you for the zeros of these polynomials and ask you for multiplicity, and these things you can find from the graph. But the intention, the idea is if you find those first, it might actually help graph easier. So I guess let's start off with, this was within the second graph we looked at on Tuesday. And so you guys already have this in your notes, you already know what this looks like. So again, so what I want to do is kind of take two on this. Let's figure out some stuff about the function before we figure out the graph and see if that helps us, see if you like that way of getting the graph. So, one of the things you can figure out about this before you even get a graph going, we talked about this on Tuesdays, you can figure out the end behavior. So again, we don't have the picture. But we already know what the end behavior is going to look like. So what about this tells us the end behavior? Highest power. The highest power. So the highest power is an x to the fourth. So this is going to look like an x to the fourth graph on the ends, on the left and the right. So what is my end behavior? Yeah. So, and I'm going to use words, but you're exactly right. So on the left, it goes up or it goes to positive infinity. So, well, tell me the difference. So don't just, it's not that you got it, but you're all looking at it just like you and I thought. So how do you tell the difference?
We said that the even, it's different than the odd.
Yes. So when it's even, so if you have x to an even power, what does that graph look like? Go ahead. Say it again.
Like quadratic.
Yeah, it looks like a quadratic. So this is the thing you gotta know. So I will say that always at this point in the class, especially for the non-engineering version of this class, people are like, oh, I have to memorize those pictures. Yes, so the only way to get behavior is not this rigorously operating. You have to memorize the pictures. Every even graph, it looks essentially like a U. And that's how you know when to get. It's the same end behavior, same end. What about if it's odd? That's going to be an x. So write this down. I mean, I'm sure you have it, but write it down in your notes and memorize this. This was the conclusion. We said this in words. I got you guys to say it. You guys actually came across this pattern very naturally before I even really prompted you guys for. So this is the pattern. This is the thing about my strategy. So we already know if I'm, my end goal is I'm gonna have a graph of this thing, but I already know that on the left side it goes up and on the right side it also goes up. And I want to take you back to, so the couple weeks before, not just a couple weeks before spring break, but even going back to the first couple weeks of class, one of the things that we would figure out about our graphs, is x-intercepts. So the next thing that I want to figure out about this polynomial without looking at the graph, so I want to figure out the x-intercepts. And for polynomials, they call the x-intercepts zeros. Which you'll probably kind of see why I call it that. But I honestly don't want you to worry about the new word. Just know that when they say zeros, they mean x-intercepts. X-intercepts you already know how to find. So then we did this for 2 weeks before, first 2 weeks of class, 2 weeks before spring break. So how do I find the x-intercept for any function? If it doesn't immediately come to mind, go ahead. Actually, let me give you guys a couple minutes. So even for if it immediately comes to mind, just hold on for a second. But what do you call it? I'll have you guys look back. So I'll give you guys a couple minutes. Go back in your notes, find a problem where we found x-intercepts. See if you can figure out what to do.
Like what happened?
What do you guys see in your, so we found an x-intercept. So y, that y equals zero. So remember x-intercepts, we know that the y value is zero. And that's all you ever need to know. So, yeah, every single time we've done it in this class so far, so I want you guys to see these similarities. So when I keep saying this, it's not to like drill it into, what I'm saying is, that's how learning works. If you see something happening the same way every time, then you have to realize that you don't have to memorize, you just have to set that pattern in your head and trust that it works the same way. But every single time we found an x-intercept so far this semester, we have plugged in zero for the y value and then solved that equation. That's the solving of the equation that's been different every time, and that is the nature of what you're going to look at. So we're gonna set y equal to zero, and then it's up to you to figure out how do I solve that. 0 equals x to the fourth minus 4x squared. Then looking at that, and again, look back at your notes, I gave you guys a summary of like when you see an equation, there's two different ways to solve an equation. Wait, there's a tell, there's a way to know which way are we gonna go with this? So part of what I'm gonna do is I'm gonna ask you guys these questions to get you to answer them, because I promise you, this is the way you have to think through every single time you solve an equation. So again, the other thing that I'm trying to get you guys to see that is that you have 1,000 different problems in this class, but you don't have 1,000 different ways to do the problems. I promise you, by the end of college algebra, you have about 15 things that you do. And every problem is one or two or three of those 15 things. So I'm trying to get you guys to not memorize how to do these problems, but think about what is one of those things that I'm doing in this problem. Surprisingly not. I mean, there's a point where we might take a square root. So go back and look at your notes. I gave you guys.
Factory, yeah, there's that. Factory.
Yeah, so there was either factoring, so your two major ways of solving equations, either get x by itself or factor. I told you guys 98% of the equations you're ever gonna run across are those two things. So next week when we solve an equation, after the next test, the last third of the class, when I have you solve equations, I promise you guys it's gonna be the same thing. So you never wanna look at this and be like, how do I do this problem? You wanna think, am I factoring or am I getting x by itself? And it is factoring, but what's the tell? How do you know that it's factoring? Exponents don't match. Because the exponents don't match. And that's all you ever have to think about to tell yourself how to go through the problem. As long as the exponents don't match, then you can factor. So again, this is where I'm saying that is the thing we should memorize. You should not be memorizing how to do these problems. You should be memorizing if I see different powers, then automatically it's factoring. But once you know that you're factoring, then for factoring, I gave you guys 3 different types of factoring, but I was telling you guys that unlike maybe equation solving, every time you factor, you're just gonna run down and check. You're gonna try to factor common factors first. Half the time you'll have them, and half the time you won't. You need to figure out what. You're gonna check for common factors first. And then the second type of factoring was breaking it down into parentheses, so then you want to try that. And then if neither of those work, you want to do looping. So every time you know that you got to factor this thing, you're actually going to run the same process. Check for common factors, try to factor it in 2 parentheses, if neither of those work. What do you guys see here? Do we have a common factor? You do in this case, so x squared, so factor out an x squared. And so I'll give you guys just a minute. Go ahead and factor out the x squared if you haven't already. But go ahead and factor out the x squared. So what are you guys getting left over here? So x squared times what? X squared for it. So x squared times x squared gives you x to the 4th, minus 4 x squared. And then especially because this is a squared, the next thing you want to check is if you can factor this x squared minus 4 2 parentheses. Which I'll tell you guys you can. So I'll give you another minute or two. Go ahead and try and factor this into 2 parentheses. So what are y'all guessing for the 2 parentheses? X plus 2 and x plus 2 and x plus 2. And then from there, how to solve for x? What do we do? That is equal to notice we're gonna have 3 kind of pieces here, so 3, then 3x intercepts. So x squared equals 0, x plus 2 equals 0, x minus 2 equals 0. So what do we get for our x-intercepts? So not just -2 and +2.
2, 0, negative.
Yeah. Yeah, So we get x equals 0 from the first factor. Then x equals -2, the second factor, and x equals 2, the third factor. And so if they're asking for zeros, you're allowed to write it this way, just x equals, what is the x next to y 0? But like we've been doing kind of all through the semester, though, I really want to use this x-intercept. So how would you write the x-intercepts? 0, 0. -2, 0. Those are my x-intercepts or zeros. Think so something new we see for polynomials that they're asked for. So we'll get to the y-intercepts, but they ask for what's called the multiplicity of these zeros or x-intercepts. And maybe to give you some sort of connection, so once we get the graph, we have a much better connection, but without the graph, multiplicity, the root word is multiple. What is multiple? We'll get it. Multiplication.
More than one.
Yeah, more than one. Yeah, so it's simpler, just more than one, right? So multiple is telling how many of something you have, right? So the multiplicity of each of these zeros or x-intercepts is the power that each of the factors have that it came. So for instance, x equals 0 came from x squared, and what is the power of x squared? 2. Yeah. So the multiplicity here for that one is going to be 2. And x equals -2 came from x plus 2, and what power does x plus 2 have? 1. Multiplicity there is 1. Literally just saying, what they're really trying to do is they're saying how many of those factors. X squared is 2x plus 2 of those factors. But an x plus 2 is just an x plus 2. You just have 1. So then the same for x minus 2. What's the multiplicity for x minus 2? For x equals 2. Well, just 1. Then again, like we've been doing all semester, how long the y-intercept of this? How would I find that? Say it's very good. Yeah, so x equals 0. Y equals 0 to the 4th minus 4 times 0 squared. And what does that mean? It's weird. And we're yeah, 0, 0. Good. Well, y-intercept is 0, so. And b equals this. So this seems like a lot of work to do before you even like set up a graph, right? So why would we do this? So let's try to set up the graph from this information. Let's kind of see what parts of the graph it means. So what I now know, first of all, I know that on the left end and the right end, this graph is kind of going up. So I keep that in my mind. But notice by finding the zeros, by finding the x-intercepts and the y-intercepts, I now have a lot of points actually for the graph. So I know that the graph has an x-intercept at -2, 0, at 0, 0, at 2, 0. I know that the graph is kind of going up on the left and up on the right. So then to finish out the graph, what x values would I need to pick to kind of figure out the rest of it? don't see that's okay. So part of it is I want to see if you use. Don't.
I didn't find the record ones.
Yeah, and why the ones?
In this case, trying to see if it's going like curving down or curving upward.
Okay, good. So we kind of know that the graph is going up here, but we don't know what's happening between these two. So technically, all I need to do to finish out this graph is to figure out what's happening between my x-intercepts. So I can just get, yeah, I'm gonna need a table, but I don't need all of the points because I already have a bunch of them. So basically, I already have -2, 0, and 0, 0, and 2, 0. So I can pick some of the numbers in between. Then plug those in and figure out the y values. And again, this is the graph we did at the end on Tuesday, so I'm just gonna go ahead and mark what we already figured out. We figured out that -1 gave us a -3 and 1 also gave us a -3. That would be there. And once you have those two, how do you draw the graph? What does it look like? There, yeah. So just notice that once you have all that, then actually draw the graph. Draw our W from there, and it's the exact same graph or sketch that we end up with Tuesday. I guess my question to you guys is then, having seen that, do you like this way of getting the graph of a polynomial better, or do you like what we did on Tuesday, that we just picked x's? Tuesday, what about the rest of y'all?
I feel like it depends.
Yeah. I will say that, so occasionally you're gonna get a complicated function, especially where your x-intercepts are like square roots or just values of nice integers. Yeah, when you come across those, this is actually the only way to figure out the x-intercepts exactly. But good, but just what about the rest of y'all overall? Like,
Same.
so Tuesday,
The same, like if the function seems not that difficult, they just do and get too good.
okay.
Same.
So it sounds like if this function doesn't look difficult, then you guys are just gonna take the approach as Tuesday, which is good. So let's say you take the approach, like on the homework, you're gonna see problems and they're gonna ask you for the zeros or the x-intercepts, the multiplicity. Let's take the approach of, on the homework problem, they're gonna give you the polynomial, and so what you guys are gonna do, the first thing you do is you're gonna graph. You're gonna get the graph. So then they're gonna ask you for the x-intercepts. How do you find the x-intercepts on the graph? Or they're gonna ask you for the zeros.
Would be with the minus cards.
I'll see that steps.
Yeah, so as long as the numbers are nice, then like, again, so what I'm saying is, if y'all are more comfortable with doing the graph first, then take that approach. And all you gotta know is they're gonna ask you for the zeros, well, that's just your x-intercepts, so just tell them the x-intercepts. They're gonna ask you for the y-intercepts, just tell them the y-intercept. The one thing that we gotta kind of connect to the graph is what does the multiplicity mean for the graph? Because multiplicity we got from looking at the powers of the factors. So if you do the graph, you're not gonna have to do that. So what I want you guys to notice on the graph, 2 and -2 both had a multiplicity of 1. And notice what's happening, at those x-intercepts, what's happening with the line on the graph? It passes through the x-axis. They asked questions, but we knew exactly where it was. So notice that at 2 and -2, the graph crosses through the x-axis. And if you think about something, if you think about an x to the first power, if you just think about x to any odd power, if you think about all those graphs, y equals x, x cubed, x to the fifth, on all those graphs, the graph crosses through the x-axis. So this is actually, again, going to go back to those power functions. If your multiplicity is odd, that actually tells you that it crosses through the x-axis of the graph. And so you can apply that backwards. If you see it crossing through, you know the multiplicity is off. For the sake of this homework, that means that your multiplicity is 1. They're not giving you any crazy function on this homework where the multiplicity is 3 or 5 or anything. So if that's what, so once you guys got the graph, if you see it crossing through, that means your multiplicity is 1. But then notice in the middle here, the graph doesn't cross through the x-axis. How would you describe what's happening there? What's happening at 0, 0? The graph, the x-axis. Break. It's kind of a break. So, because crossing through looks like this, right? Like it physically goes through the x-axis. So how would you describe, it's not going through the x-axis here, how would you describe what it's doing here? So there's a couple different ways. The books tend to use the term touch and turn, so it touches and then turns back. I use the term bounce. Really, we drop the bouncy ball and it just bounces back, right? So it doesn't go through, it bounces back. So whichever term you want to use there, but there's a different big crossing through, it's hitting and coming back. But notice that that kind of looks like a square or a fourth power. It kind of looks like what happens. So if you think back to an x squared or an x to the fourth or an x to the sixth, all of those functions at the x-axis bounce and come back here. So if you see something like that, that means your multiplicity is even, which means for the sake of this homework, that means the multiplicity is 2. So you can even tell the multiplicity from the graph, since that's the wrinkle scrolling. So the 2 means, so if your factoring goes to 2, it's actually your power. So like x equals 0 from x squared, the power on the x. Yeah. So that's what we're doing. So I'll give you guys another one of these and sounds like you'll approach it for me to graph it first. So graph it first, and you're still gonna tell me all the stuff. So tell me end behavior, tell me zeros or x-intercepts, multiplicity of y. So the order is 20. So I'll give you guys a bit of time, go ahead and like I said, graph it, and then I know that's what I always say.
One, but that, as it would mean. Like, you just want to.
I mean, for the sake of the court, just number down. Yeah, just know how to write it the other way. Yeah. I didn't see what this. Brother. Anyone's gonna like. Wait. I'm ready for it. Put your money into me.
Feature.
It ends up on that one. Google. It's sort of, it doesn't get user tolerant, so it sort of is the part of the person. Yeah, it'll yeah. But so if not, then just go ahead. Just try to plug in next values and get it right.
Wait,
It looks
this is big game.
seriously.
Negative side. What's kind of like really Jennifer? The pigeons running from this like road now. In my fucking ground. It goes fucking roller coaster, bro. No way, I need one.
What the? Sitting. Oh, yeah, that was actually, we should have got that yesterday. That's one I forgot about that. Yeah.
Why do you put the right inside? Hold on. And then I do.
No,
Let me see. Oh, I got the two. Well, two is negative two. You're gonna bet money? Bet money. I wish out. I'll give it Albert. How much you gonna lose? How much you gonna lose? You could see some of this calculated future.
make sure.
Oh, yeah.
It's -3.
Wait, oh, yeah, yeah. Oh. For two?
For negative.
For two.
Oh, yeah.
Oh. Wait, for negative two is three though?
-6.
Well, the most basically.
Then I'll get negative one. Takes you in.
So for instance.
Or.
For -1.
It's okay. You get the just like the number.
No. Like either, that would be like, but.
So both of those though, X plus one, X plus one, just that.
No, I still work. Wait, no, wait, but you said we. I think calculators or something. Oh, yeah, it didn't add the exponent of three. Bruh, that's so crazy. So. Gosh, got it. It's hard. This calculator's like really crazy. Wow, I'm still getting more. Graphs in you.
Percent for the zeros after you guys get the straights. Yes. You just.
Yeah.
Oh, it's also three. A negative.
Oh, yeah.
Add one.
So you get it. You get it. Okay, supper is really okay. I was just doing yeah.
By the way, that's all in there. Feel like this. Here's Dave.
It's negative 48. For three,
And negative. Yeah.
four, going.
Right.
What?
Alright, so let's kind of take a look at this. So I think this kind of watching you guys is so a couple people kind of didn't have an idea where to go, but most of you guys had an idea where to go, but shows very different approach to this. So I saw some people going through finding this stuff first. I saw some people just basically picking numbers to find the x-intercepts. And then I saw some people actually getting the whole table built. So that is actually really, I want you guys to go with kind of what works best for you. It does make presenting this in class hard, because I do have to sort of major on one method. So I think I'll major on, so I mean, like I was saying, it's, most of y'all seem much more comfortable with getting the graph going, like building the table and getting the graph going. For those that were picking x's, that are basically working the x's through and figuring out the x-intercepts, the ones that gave you 0, you were doing the same thing, you just didn't record all the activity. we go. So let's kind of start there. So what X values did y'all end up choosing?
Like,
Okay. So you started with -2, -1, 0, 1, and 2, and then after you kind of went through those, did you expand beyond that?
yeah.
Okay,
Yes.
and why did you end up expanding beyond that?
I don't know.
Okay, that's a five angle, yeah. Cause yeah, so what you should have found here is there's at least one x-intercept that's beyond here at, should be at -3. Yeah. And then you'll need, again, you can already guess the end behavior actually before we start, but if you didn't do that, then yeah, you would have needed a couple. So you probably need roughly something like this. So, let's say when y'all plugged in -4, what did you get for this? 15, let me make sure that sounds about right. So 64, 48, 60 -1. Yes, that is 15. Good. What about -3? -3 gives you 0. What about -2? Yeah, -3. What about -1? -1 gives you 0. 0 gives you 3. 1 gives you 2. And 2
Negative.
was, I think, a -15. And what about 3?
Uh,
-48. So you roughly might have got to this point. Notice, so something we did talk about, just a brief bit on Tuesday. Notice you end up with 3, so I can already see 3 x-intercepts or 3 zeros here. My highest power is 3, so again, that highest power will tell you the most number of x-intercepts. Doesn't mean you'll always get 3 x-intercepts or a third power, but at the most you can get 3. So you'll never get 4 x-intercepts out of a third power. That's a good thing to just know to check on when you're doing your calculations. So if I give you a third power equation on the test and you work through the calculations and you get 4 zeros, you know you did something wrong with one of those. Okay, so let's graph this as it is. Let's see, so -4, way up here. Then -3, 0. -2, -3. 1, 0, 0, 3, 1, 0. 2 way down here, etc. So then, how would you draw the graph from there? So it starts up here. Back up there and then back down. And then they're gonna ask to permit information express. So what's my end behavior? Yeah. So left up,
Oh, right down.
right down. What are my, well, I'll use their word, what are my x-intercepts or what are my zeros here?
It's 3, 0, negative 1, 0, 1.
Yes. So -3, 0. -1, 0. 1, 0. And then what is my multiplicity at each of these? Oh, and again, if we don't have the factors, what you're looking for is, so what happens, what does the graph do at the x-intercepts, at each of these x-intercepts?
I'll be on this.
Yeah. So notice this crosses through. So when I say, so again, looking at that last graph, so I think the bouncing thing, the last class was having a little bit of trouble with this too. When I say bouncing, I mean bouncing at the x-axis. You're always gonna have a valid. This thing is always gonna turn directions. So it's not whether you see this, it's whether you see this at the x-axis. So notice here it crosses through. So if I just look, I just take a picture near the x-axis, that's just crossing through. The same here, that's just crossing through. And the same here, that's just crossing through. So my multiplicity on each of these is gonna be one, so it's gonna be one there, or one
does
there.
count.
Yeah. Yeah, it doesn't bounce at the x-axis.
Okay,
That's
so
what
it
it
goes.
Yeah. And then what's my y-intercept on this?
Is zero.
0. That's everything they're gonna ask. Well, that's what I was saying, I was trying to figure out one or you take either flat or you all start forward, or you grab, you know. Any good question, any other questions? Then that's honestly it, that's the rest of your homework, it's just, they're gonna give you this, you graph it, and then you tell them all the stuff they see. That's, yeah,
So this one, we think would it work?
grouping would work on this one. So So with the factoring on this, so if you went that direction. So I'm gonna start some grouping, I'm gonna group the first two together. And then group the last two. And I'm looking for common factors, and so on this one. So what's the common factor on the first two that you see? X squared, because you have a leading negative here, you should factor out everything. That's probably what threw you off. Factor out negative x squared. Because when you do that, that flips the signs, and so it'll be negative x squared times x times positive 3. Now the second two don't really have a common factor. So you basically just have to remember then that that's a 1, so you can treat it like it, so that's 1 times x plus. Because then x plus 3 is my common factor for the second half of this. So I'm gonna factor out x plus 3. My common factor. That leaves me with 1 minus x squared. And that's the grouping part. What do you think, Trio? Or does it make sense at least? Yes, okay. And I will say from here, so it's grouping, but you can factor this farther into 2 parentheses, the 1 minus x squared. So you end up with 0 equals x plus 3 times 1 minus x times 1 plus x. That's like the full factor. Good. What other questions? So, the factoring will come up more, we'll keep, I mean, you'll kind of see it, it'll honestly be annoying, but basically like, I think I was. Maybe it was in y'all's class, it was the previous class. But to me, and when I think about college algebra is 15 things, basically 15 ideas, concepts, tools that get you any problem you'll ever see in college algebra. And factoring is the tool that you use almost every, just almost every, after a certain point, you just use it in almost every problem. So we'll get a ton more practice. All right, then that is good for this week. Next week we'll come back and look at, they're called rational functions.
I went down the part the most
It's only for. Yeah.
like Portland with there. Like,
I've never seen something, so I do, when the site sure is, in case I had all about the class insurance, so sale. So it's like. Like I was sleeping, not sleeping, and that like each other, like. That's not that hard, so hard. Nice.